All right. So this is actually the last section of the chapter. 4, 6. Let me get there. Okay. So to start out, let's do, I'm going to give you 3 pairs of triangles, and I want you to tell me, can you prove they're congruent? I want you to write a congruent statement if you can and tell me what postulate or theorem lets you know. Okay? So here's the first one. Okay. Let me give you all some time to copy those. So I want you to write a congruent statement if they're congruent, and what postulate or theorem you used if you could. Or state that they are not congruent. Or not that they're not, that they can't be proven. Okay? So the first one, are they congruent? Yes or no? Yes. So let's state the congruence first. So triangle, I'll call the first one ABC, is congruent to, okay, what corresponds to A on this triangle? Sorry? D. What corresponds to B? E. And that leaves F. So they're actually both in the right order. Okay? What postulate or theorem let you know these two were congruent?
Side angle side.
Side angle side. Because you know two sides and the included angle. Okay? Remember, if you know two sides and an angle, it has to be the included angle. Otherwise, it's angle side side, and we don't want that. Okay? All right, what about the second one? Triangle GHI is congruent to triangle what? What corresponds to G on this triangle?
C.
C. What corresponds to H?
X.
X. And what corresponds to I?
M.
M. What theorem or postulate?
Angle side angle.
Angle side angle. Because it's two angles of this triangle to two angles of this triangle and the included side. Okay. What about the third one? Yes, it's angle, angle, side. You're right. And it is triangle MNP corresponds to or is congruent to AXC. Everybody got it? Now, if you wrote the first letters in a different order, the second one would have to be in a different order. There's different ways to do that. Okay. Well, now you need your note cards out because we're going to learn two theorems and two corollaries. Okay? And as we do with theorems, we have to prove them the first time, but then you can use them and have that knowledge forevermore. All right? So the first one, I'm going to write the theorem, and then I'm going to give you the kind of the abbreviation that you can use in a proof. And it says, and it's called the isosceles triangle theorem, but again, I wouldn't get hung up on the names of the theorem, just what they say, okay? And it says, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So visually what that means is, now why would this be called, hold on, I'll get back to that. Why would this be called the isosceles triangle theorem?
Because there's two or more sides.
If two sides of a triangle are congruent, well, that's an isosceles triangle, okay? So really it says if it's an isosceles triangle, then the angles opposite those sides, which in an isosceles triangle, those are called base angles are congruent. So that means if I told you that AB was congruent to AC, what this theorem says is that also means what angle is opposite AB?
AC.
You can never name an angle with two letters.
C.
C, or you could call it ACB or BCA. So the angle across from this is angle C, is congruent to the angle across from this, which is angle B. So that says if you know two sides of a triangle are congruent, then you know the two angles across from those sides are congruent. Now, how is this different from the triangle theorems we've been learning? The ones we've been learning have been dealing with two triangles. And this is just in one triangle. In one triangle, if two sides are congruent, then the two angles are also congruent. Okay? Now, the way you write this in a proof is if sides, then angles. Much better than writing all of that for your reason. Okay? So let's prove it. Okay. Now, we're really only talking about the big triangle, PQR, right? I'm saying in the big triangle PQR, this side's congruent to this side. So do you see how the big triangle is an isosceles triangle? Okay. So according to that theorem, if that's an isosceles triangle, angle P should be congruent to angle R, right? Now I divided it into two triangles so that we can use the theorems we've already learned this chapter. But we're really proving something about just the big triangle. So first, just put what we're given. PQ is congruent to QR. And that was given. Okay. Well, what we could do is, if we could prove these two triangles were congruent, then angle P and angle R would be corresponding parts, and CP, CTC. Corresponding parts, congruent triangles are congruent. So, remember, go over on your scrap paper and write all the ways you can prove two triangles are congruent. You got side, 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 angle, angle, side, angle, and angle, angle, side. Okay? So, what do we currently have? One side, right? One side of this triangle is congruent to one side of that one. So, all of those are still options. Okay? Can we prove one other thing I'm going to do is I'm going to, I forgot to put this in the given because your book does it a little different, because I was like, we're going to run out of ways to do this, is I want you to, PR is a segment, right? If we're thinking about this big triangle, PR is just one of the sides, right? How many midpoints does a segment have? Just one, right? Yeah. So I'm going to let S it be the midpoint of PR. Okay? So we really got this isosceles triangle that we're worried about, but I'm going to draw a line down the middle that goes to the midpoint of PR. Okay? So that's also another given. S is the midpoint of PR. Okay? So, we can't know anything from this yet. We just know one side is congruent to one side. What do we know since S is the midpoint of PR? Segment PS is congruent to segment SR. How do we know that? Definition of midpoint. Okay, so now we know two sides. What can we eliminate over here that we're not going to use?
Side.
No. Angle, angle, side, because we know two sides. Also, angle, side, angle. So we're either going to use side, 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 or side, angle, side. If we were going to use side, angle, side, what would we need to know? Which angle?
Angle P, angle R.
We would need to know that angle P is congruent to angle R. Do we know that angle P is congruent to angle R? No, that's what we're trying to prove. So we can't use side, angle, side, because the only angle we would need to know is the one that we're trying to prove. So we have to use side, side, side. So what is the third side of triangle PQS?
QS.
What is the third side of triangle QRS?
QS.
Are those two sides congruent? Why? Because it's the same thing. QS is congruent to QS. What's the reason? Reflexive property of congruence. Okay? So now we have three sides of one triangle are congruent to three sides of another. So we can say triangle QPS is congruent to triangle QRS. What's the reason? Side, side, side. What step did we say the first pair of sides were congruent? 1. What step did we say the second two sides were congruent? 3. What step did we say the third two sides were congruent? 4. Are we done with the proof?
No.
No. So since we're not done, what is the next reason always?
CPCTC.
CPCTC. Okay? Now, once you prove the three things, remember all of these need three things, right? Side, side, side needs all the sides. Side, angle, side needs two sides, one angle. Angle, side, angle needs two angles, one side. Okay? With two triangles, there's always 6 things. There's 3 sides and 3 angles. So once you've proven 3 of them and you know that the triangles are congruent, your CPCTC choices are the other 3. So if we've proven all 3 sides are congruent, what are our choices for CPCTC? The 3 angles, right? So if we needed, we could say that this angle was congruent to this one. If we needed, we could say that this angle is congruent to this one. And if we needed, we could say that this angle is congruent to this one. Which one do we need?
P and R.
Angle P is congruent to angle R by CPCTC, and we're done. So we have proven if you have an isosceles triangle and that you draw this line down the very middle of it, that you can prove these two are congruent, which means these two angles are. So in an isosceles triangle, the base angles are congruent. Okay? Well, that's actually a biconditional. Do you remember what biconditional means? It can go in both directions. So the one we just said is if two sides are congruent, then the opposite angles are. What would the reverse say? If two angles are congruent, then the opposite sides are. So let's see that. So if two angles in a triangle are congruent, then the sides opposite those two angles are congruent. In a proof, you would write if angles, then sides. Okay, so let's prove this theorem. So what we've got is, we've got a triangle, and we're going to call it, really creative, ABC. And I'm going to give you that angle A is congruent to angle C, and I want you to prove that segment AB is congruent to segment BC. Okay? So, now the one we just did, if you look back, it's proven in your book. And so if you're looking back and you're confused and you're trying to study this later, your book does something a little different than I did. Instead of giving you that S is the midpoint, what it does is one of its steps is draw the line QS so that S is the midpoint. Okay? And so you draw a line. And so just so that I sometimes do it that way, sometimes not. I'm okay with either way. But just so you can get a feel for both ways, I'm going to do that on this one. Okay? I'm going to make the step where you draw that line one of the steps in the proof. Okay? So, first we're going to write what we were given. Angle A is congruent to angle C. Given. Okay? Well, the problem with us being stuck now is that up until this point, the only triangle theorems we have are when you have two congruent triangles. Okay? So what we need to do is divide this triangle into two congruent triangles. And so my next step is going to be draw BD, the angle bisector of angle ABC. So what am I saying? I want us to draw a line here. Call it BD, that cuts this angle in half. Okay? And the reason is every angle has one angle bisector. Just like before, we said that every segment only has one midpoint, right? Okay? So what do we know if we know that is the angle bisector? We know that angle ABD is congruent to angle CBD. ABD is congruent to CBD, right? What's the reason for that? Definition of angle bisector. Definition of angle bisector says that it is a line that cuts an angle into two congruent angles. All right, so over here on your scrap paper, you've got side, 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 angle, angle, and angle, angle, side. Which ones can we eliminate? I'm sorry?
Yes,
side, 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 and side, angle, side, because we already know two angles. So the great thing about knowing two angles is you only have to prove any side. Because we have a theorem or a postulate that says if it's the included side, and we have a postulate that says if it's not an included side. So if you know two angles of one triangle are congruent to two angles of another, then all you have to do is find any pair of sides on both triangles that's congruent. What would that be? Is there a line on ABD that you know is congruent to a line on CBD? Yes, BD. Because it's in both triangles. So we know that BD is congruent to BD. What's the reason? Reflexive property of congruence. So now we've got it. We've got two angles. Do we have an included side or a non-included side? None. The included side would be AB and BC, which is what we're trying to prove. So we know that triangle ABD is congruent to triangle CBD. The reason is angle, angle, side. Now, what step did we say the first pair of angles were congruent? Step 1. What step did we say the second pair of angles were congruent?
4.
No.
3.
4 has nothing to do with angles, so it's 3. And then what step did we say the pair of sides were congruent?
4.
4. Okay. Are we done?
Nope.
No. So the next reason has to be CPCTC. Now we've proven 2 angles and a side. So what are our choices for the CPCTC? We can either say the third pair of angles are congruent, right? So we could say, if we wanted, that angle BDA is congruent to angle BDC. Is that what we need? No. We could say that this side is congruent to that side. We could say that AD is congruent to BDC. That's not what we need either. We could say the third sides are congruent. That's what we needed. So we can say that AB is congruent to BC by CPCTC. And so we have now proven that in an isosceles triangle, or in any triangle, if 2 angles are congruent, then the sides opposite those 2 angles are congruent. Okay? All right. So now we have 2 corollaries. Now corollaries, you can put them on your note cards because I don't mind you using them. But what corollary means is it could be proven easily right after a theorem you just learned. Okay? So it's not enough new information to be its own theorem, but it's a little step further than the theorem you just learned. So I'm going to prove both of them really quickly. Okay, so the first one says a triangle is equilateral if and only if it is equiangular. Okay, so let's prove that. Since it's an if and only if, we have to prove both directions, right? So first I'm going to prove that if a triangle is equilateral, then it is equiangular. Then I'm going to prove if a triangle is equiangular, then it is equilateral. Okay, so the first one, we're going to have a triangle, let's call it XYZ. So we're going to be given what? If we're trying to prove this first statement, what are we going to be given and what are we trying to prove? We're going to be given that triangle XYZ is equilateral. And we're going to try to prove that triangle XYZ is equiangular. Right? It's a pretty short proof. Number 1, triangle XYZ is equilateral. That is given. Okay, what do we know if it's equilateral? All the sides are congruent. So we know that XY is congruent to YZ is congruent to XZ. And that is definition of equilateral. Well, ignore this side for a second. We have two sides of a triangle that are congruent. What did we just learn that means? It's isosceles, but what did the theorem tell us also it means? If two sides are congruent, the angles opposite of them are congruent. So since xy is congruent to xz, we know that angle y is congruent to angle z. And the reason is, if opposite sides are congruent, then opposite angles. We just proved that. Okay, now let's ignore this side for a second. We have two sides of a triangle that are congruent, right? Two sides. So the angles opposite those sides. So angle y is congruent to angle x, right? So the next one is, since YZ is congruent to ZX, angle Y is congruent to angle X. Oh, what just happened? Okay. All right, so here we go. So we're back. Since YZ is congruent to ZX, so if you're just looking at these two sides, then if two sides are congruent, the angles opposite those. So we know that angle Y is congruent to angle X. And the reason is just like before, if opposite sides are congruent, then opposite angles are congruent. Well, look at what you have. X is congruent to Y and Y is congruent to Z. So what that means is angle X is congruent to angle Y is congruent to angle Z by the transitive property. Right? And then we got it. If all three angles of a triangle are congruent, then what? We can call triangle XYZ is equiangular. And the reason is definition of equiangular. Okay? Now the reverse is really easy. If you knew it was equiangular, you would know all three angles are congruent, right? Mm-hmm. And if two angles are congruent, then the sides across of them have to be congruent. And if two other angles are congruent, the sides across from them have to be congruent. So all three sides are congruent, so it's equilateral. So I'm not going to do that proof because it's really just this one in reverse. The only thing that's different is instead of if sides then angles, you have if angles then sides. Okay? But then it's just this exact proof in reverse. Okay? All right, you've got one last corollary we're going to do before you start your homework. And that says, and this is something you already know actually, that each angle in an equilateral triangle is 60 degrees. Okay, so let's prove it. And after we prove it, you can just use it. So you're going to be given triangle ABC is equilateral, and I want you to prove that the measure of angle A equals the measure of angle B equals the measure of angle C equals 60 degrees. Okay? Well, it's pretty short proof as well. You start with triangle ABC is equilateral. What's the reason? Given. Always going to get that one right. Okay, well, we just proved that that also means that triangle ABC is equiangular, because a triangle is equilateral if and only if it is equiangular. Well, that means that angle A is congruent to angle B is congruent to angle C. That is the definition of equiangular, right? Which means that the measure of angle A equals the measure of angle B equals the measure of angle C. How'd I know that? Definition of congruent. Congruent angles specifically. If angles are congruent, their measure is congruent. Well, we also know that the measure of angle A plus the measure of angle B plus the measure of angle C is what? 180, because the triangle sum theorem. Or you could just say the three angles of a triangle add up to 180. Well, they're all equal though, right? So I could write the measure of angle A plus the measure of angle A plus the measure of angle A equals 180. Right? That is substitution with steps 4 and 5. Since A is equal to all those, I plug A in for all of them. Well, what's the measure of angle A plus the measure of angle A plus the measure of angle A? It is 3 measure of angle A's equals 180, right? And that is just called, I call it simplification. Well, then what can we do? Divide both sides by 3 and get the measure of angle A is 60 degrees. That is the division property of equality. Well, A is equal to B is equal to C, and A is 60. So that means measure of angle A equals the measure of angle B equals the measure of angle C equals 60 degrees. And that is the transitive property with steps 4 and 8. Right? Because 4 said they're all equal, and 8 said A was 60, so that means they're all 60. And we're done. Okay, your homework is page 225, 15 through 47, odd. And I moved 4.4 and 4.5 quiz on Friday. And that was off the screen. So there you go. All right. Yes. Yes. It's funny. That's the last thing that's going to be on the video. Can I go to the restroom?